We're continuing with vector day 2, the notes from vector day 2. So I think I had gotten in the previous video down to this point where we talked about what it means to be parallel. So if it says find all vectors parallel to that, then basically that means we can take this vector and multiply it by any non-zero scalar. So find all vectors, okay, so it's just k times 1, 4, negative 3, where k is not equal to 0. All right, continuing on. It says find a vector parallel to that with a magnitude of 2. Okay, so the first thing we want to do is we need to figure out what its magnitude is. And its magnitude, you'll remember, we take the square root of each of these things squared. So this is 1 plus 16 plus 9. And that gives us, what is that, root 26? So this vector right here has a magnitude of root 26. So if we want to find it, to have a magnitude of 1, then we have to multiply it by 1 over root 26. So this, like if I took this vector, 1, 4, negative 3, and I multiplied it by 1 over root 26, so there's a 1 right there, then this one distributing through, it's 1 root 120, never mind. It's a fraction of that. Okay, well, let me try it. Let me try a slightly different thing here real fast. Say I've got this vector 3, 4. Okay, you know that the magnitude of this vector 3, 4 is going to be equal to 5. Okay, that's a 3, 4, 5 triangle. We've gone 3 units in the x and 4 units in the y, and that if this is 3 and this is 4, that has to be 5. Okay, so if I want a vector that's parallel to this but is only a unit vector, then what I want is something that's a fifth of that length. Okay, because there's 5 of these little unit vectors that are gonna get that add up to give us this magnitude of 5. So if I have the vector, I could say it's 1/5, 3, 4, which would be equal to, you could tell me that this is 3 over 5 and 4 over 5, or you could tell me that this is equal to 0.6 and then 0.8. These vectors, you could, and I'm happy with any of those representations. Those vectors would be a unit vector parallel to this vector. Okay, so same idea. This was a little bit more involved of a problem, but the unit vector would be when I multiply this by 1 over root 26. But I want it to have a magnitude of 2, so I need to get it to a magnitude of 1 and then multiply by 2. So what I'm really going to do is just say that this k value that I want to use is 2 over root 26. There's not really a good reason for us to rationalize the denominator, and it doesn't really matter if we distribute it through. We can, but I'm content with this right here. Okay, so it says find a vector in the opposite direction to this with a length of that. Well, we already know this is the same vector. We already know that it's got a magnitude of root 26, so if we want it to have a magnitude of 3 times root 26, that means we just need it to be 3 times as long as what it currently is. But in opposite direction, that means that our k value here is going to be equal to negative 3. So this becomes, well, a negative 3 times 1, 4, negative 3 would be equal to negative 3, negative 12, positive 9. So there's that vector. Okay, so the next one here, use that vector to determine the type of quadrilateral. First thing I would do is draw some sort of a quadrilateral and label so that I can see what my vectors are doing. Okay, they tell us A, B, C, D, so it's important to go in order. I don't care where you start. I don't care if it's drawn to scale. You just need to go in order. Okay, so if I look at, well, I know that if vector AB and vector DC are equal, let's see, let's figure out what vector AB is and vector DC. Have we already talked about using points and coming up with vectors? I'm making these videos a few days later, so I had forgotten where we've gotten to. Given the points, well, just in case I haven't talked about it yet or whatever. If I'm here at the origin and I have this and I want vector, okay, so let's say this is A, this is B, and here's O, and I want to get vector AB. Vector AB would be equal to, well, I want to start here and end here. I'm sorry if this is a review and it's already in another video. It was moving day to day. I don't know anything. Okay, so I'm starting here and I'm ending here, so I have to go negative OA plus vector OB to go in that direction. So what we'll do when we find this vector AB is I'm going to take OB and subtract away OA. In other words, if I'm looking for this, I'm going to turn the coordinates of point B into a vector and subtract away the coordinates of point A that have been turned into a vector. Let me show you what I mean. Okay, so vector AB, I want to do 11 minus a negative 1 is 12. 9 minus 3 is 6. 1 minus 4 is negative 3. And then I want CD, so 17 minus 5 is 12. 4 minus a negative 2 is 6. This is promising already. Negative 3 minus 0 is negative 3. Okay, so we know that AB and DC are the same, which tells us that these vectors are parallel and they're equal. Okay, and so when my vectors, this vector here and this vector here, they're parallel, well, they're congruent, and they're parallel. That's it's been too long since I taught geometry, but that's how we would label that. That tells us that it must be a parallelogram. Okay, now the question is it a rhombus? Is it a rectangle? Could it be a square? Okay, so if we eliminate either rhombus or rectangle, then we automatically eliminate square. So on this one, I'm going to look and see, okay, well, what's vector, I don't know, BC? Vector BC, this becomes 17 minus 11 is 6. That's a negative 5. 4 minus 9. Okay, this negative 3, that's a negative 4. Okay, so what I need to look at is I want the magnitude of BC. And that's, what is this going to be? 36 plus 25 plus 16. Well, the magnitude of AB, I'm sorry, am I hanging off the page? Is going to be equal to 144 plus 36 plus 9. Well, notice this is already going to be bigger. Oh, I did the wrong thing. I'm so sorry. That should be the square root sign. It really is moving day, I promise. I'm just back into my classroom. This is like root 189, I think, and then this becomes, well, add 5 to that, we're at 41, 61, add 16, that's 67, that's 77. So this is equal to root 77. Those are not the same, okay? Since those two different vectors had different magnitudes, we know that it's not a rhombus, therefore it's not a square. Now the question is it a rectangle? So we don't yet know how to measure the angle between vectors. We will find that out later, but after the first quiz for HL, anyway, we're going to do it, but not yet. So what I want to do instead is to look at the diagonals. If the diagonals have the same magnitude, then it's a rectangle. So in a rectangle, they have the diagonals are congruent. Okay, so this would be vector AC. And then vector BD, they're not going to have the same direction, but we just are concerned about their magnitude. So this vector, 17, okay, that's 18, 1, and then, what is that, negative 7? Did I do that correctly? Yeah, I think so. Okay, and then this one becomes BD. I have 5 minus 11 is 6. I have... negative 2 minus, that's negative 11, and then this gives me negative 1. Okay, so the magnitude, you know what, I'm going to grab a calculator. Okay, so I need the square root of 18 squared. Can you see what I'm doing? You cannot. Plus 1 plus, well, 7 squared is 49. There's that. The other one, it's the square root of 36 plus 121 plus 1. Okay, those are not congruent. Therefore, well, and we can kind of tell that number was so much bigger. Therefore, it's not a rectangle. So the best name for this is a parallelogram.